Hello everyone, welcome to Learn Tech. And Today we're going to learn about how we can create a redundant web service using a load balancer. So let me what we're gonna cover up in this video. I have it in my notes. So the topic is all about creating a redundant web service using a load balancer. The first thing what we're gonna do here is we will create two EC2 instance using user data uh, uh, below, which we have right here to install the Apache server. The next, we'll update the security group to allow HTTP traffic on port 80, that is for EC2 machine. And in order to create a redundant, we will make use of load balancer. So that's when we will create the load balancer. And we will also create a target group for your load balancer, that is to add the target machine, and we will uh, associate your targets with the load balancer, which is a target group, and register the two machines, which I already have mentioned in this particular row, right? So I can just remove this line. So let's go to the AWS console and start creating our first two EC2 instance using the user data to install the Apache web server. So let me minimize this and go to Safari browser. Okay, so I'm in my EC2 dashboard in AWS console where you see no instances running at this moment. So we will first need to create our two instance and install the Apache server, which is the web server. I'll click on launch instance here and I'll provide a name for my EC2 machine. That's going to be my web server 1. Okay. Uh, I'm giving this web server 1 uh, as a EC2 name, but I'm going to launch two instances with this configuration, with the same configuration. So later I can change one of the EC2 instance with server 2. So there's only option that I can keep one name, but I can create multiple EC2 instance with the same configuration. So I'll show you how we can update the name for this EC2 machine as well. In the operating system, I'll select a Linux machine, and in the AMI, which is the image for installing the operating system, I'll select Amazon Linux 2 AMI, which is a free tier eligible. Scroll down, everything is auto-populated for description and the architecture from this AMI. And for the instance type, I can select T2 Micro, which is a free tier eligible again, and this is the best instance type that I can select for this video, since it's not going to cost me any amount, right? And for the key pair, we actually don't require the key pair because we are not accessing our EC2 instance, right? We are not connecting to EC2 instance for any activity. We are just installing the Apache server and we are accessing the web server using the HTTP request from the internet. So I'll proceed without key pair for this. And for the network settings, you can leave it as default. We're not going to make any changes here, except for the fact that is security group, which we would have to allow the port or port for the HTTP request, the traffic, as I mentioned here. Uh, if I go here, so update the security group to allow HTTP traffic on port 80, right? So as I said, we would not require this, right? So instead of that, we can use allow HTTP traffic from the internet, and it will create a security group with the name launch wizard 2. Great. And configure storage will leave as it is. We are not making any changes over here. And just for your information, this is the root volume where our operating system will be installed, the Linux machine. And in the advanced details, this is where we will be installing, putting in our user data to install the HTTP service, which is the Apache service, right? So if you go to the text again, we can use this bash script, right? I'll just copy this, paste it over here. So it's a command to install the HTTPD service, which is the Apache service and Linux machine. And here what it is doing is it'll install the service. If there is any update, then it will just update those dependencies. It will install the HTTPD service. It'll start the service. It will enable this HTTPD service, which is the web service, Apache service. And it will write uh, a message, hello world, from the host name, which is $, which will be the IP address of the host name. And it will then save this particular content in the index.html file and this particular directory. Okay, so to the right hand side, it has a number of instances, which means how many number of instances you want with the same configuration. So in our case, we will use two EC2 instance. Okay, when launching more than one instance, consider EC2 auto scaling. So this is another part. I'm not covering up this auto scaling in this video. We are just using the load balancer. So everything will remain same. Just click on launch instance, right? With this, we have now created our two EC2 instance. Just click one of the EC2 instance ID. It will take you to the instance page. And you can just simply type in instance state to filter out equal to and running one. So we now have two server EC2 instance in running state. As I mentioned earlier, that the name that I provided for my EC2 instance was my web server 1, which is the same name given to the second server as well, because there was no option to provide the name individually for each server, right? So that is why I was mentioning about this in the at the time when I was providing the name for the EC2 machine. So from here, you can just simply edit and update the name. So here now I have my web server 1, my web server 2. So there are two machines that I have. And everything looks fine except the status checks, which is in initializing. It will take some time to complete its status check. And then we should be able to first test whether our HTTP request is uh, going successfully or not, right? I mean, we can also check one more thing, the security group, which uh, where we have allowed port 80 to port 80 for the incoming request, right? So if I click on launch widget 2, which is our security group, and this is the security group that we have created and assigned to our EC2 instance. And if you can see, the inbound rules has HTTP type, protocol TCP, and the 80 port source from anywhere, right? 000 means from anywhere over the internet. Anywhere, from anywhere, having the DNS or the IP address of this server can send a HTTP request. So we have the security group in place, and let me go back to the EC2 instance again and refresh. Okay, 2 of 2 check is already passed for both the machine. Now, before we create a load balancer, we can just try and check if our web service is ready to use, right? So to do that, we can simply take the IPv4 DNS of the server. So let me take the IPv4 DNS of the first instance and go on a new tab, paste, and hit enter. There it is. So it says hello world from IP so and so the host name and the AG, right? Availability zone. So we just need to verify this IP address is coming from the web server 1 machine, because that's what it was said, right? We used the DNS of the web server 1 machine. So yeah, so 172.115.24 is the same IP address that is being provided from the DNS. Okay. Similarly, we can check for the web server 2, copy the DNS, and then paste it. We have the IP address from web server 2 as well, so which is 110 ending with. Great. So we have our web server machine ready with all the setup with the HTTP service. This two server are acting as a web server for us now. And now we're going to create a load balancer. So we have updated this one, now create a load balancer, right? So let me go to the load balancer. So your load balancer, you can also navigate directly from the EC2 instance page. If you scroll down, you can click on here, load balancer, go to the load balancer page. Currently, we do not have any load balancer created. So let's create one. Create load balancer. All right. And here you have a different type of load balancer. The one which we are going to use would be the application load balancer. So click create, and then you can supply the name for your load balancer. Let's just say web server LB is the name for my load balancer. It should be internet facing so that HTTP request can be uh, forwarded to your uh, target machine from the DNS of load balancer, and it'll be IPv4. The network mapping should be, the VPC should be the same VPC on which the EC2 instance are launched. In our case, it's the default VPC, and that's the same being used for the EC2 instance. Great. Always use this one. Availability zone, you can just select all the availability zones that are within this VPC. And security groups. So remember, we have created a launch wizard 2 security group for EC2 instance. So we'll be using the same security group here, which is launch wizard 2. And now here comes the target group, which I was talking about. Load balancer target group. Create a target group for your load balancer. Add your both the instance in the target group and associate your target group with your load balancer. Great. So we're going to do this now. All right. So click on create target group. And all right. Okay. Let me click one more time. All right. Here you go. The basic configuration we need to complete here. Choose a target type, instances, IP address, Lambda function, so on. Application load balancer. So in our case, it'll be an instances because our web service is hosted in EC2 instance. So we'll just use instances and give the name for your target group. So it'll be web server TG target group. And we are choose the protocol port for your target group, right? So which will be an 80 in our case. So we'll use 80 port, and VPC will remain the same again, the default VPC. And for the health checks, uh, everything leave as it is for HTTP. Advanced health check, you can check as per your requirements. In our case, let's just reduce to this, or just leave as it is by default, and we can just click on next. And we have this two server as an available instances for your target. So we can register this two server, which is our EC2 web server 1 and web server 2, where we have the HTTP service installed, which is the Apache server, right? Web server. So it will be on port 80, include as pending below. So If you scroll down, you have this two server listed. You can just click on create target group. All right, so we have created the target group with the name web server TG, and the target machine that we have registered, it's an unused. That is because we our load balancer has not created yet, and this TG is not associated with your load balancer. So go back to the load balancer create page, and we can just refresh here, and we can select the target group that we just created. Now scroll down. We don't need to do any changes over here. Just verify that you have the name for your load balancer, which is web server LB, the security group being used, it's launch widget 2, the network mapping, everything default, and listener and routing. So it is listening on the port 80 and defaults to web server TG, which means listening on port 80 and the requests are being forwarded to web server TG group, where we have our two server as a register service, right? So we'll create load balancer. All right, successfully created load balancer web server LB. And if you see it's the status, it's showing as provisioning. So it will take some time to finish provisioning the load balancer. So we'll wait for some time here until it shows as active. Okay. Okay, let's refresh the page. Okay, still provisioning status. It will take some time here. Until then, we can just check the details. So listener and rules. The HTTP, I mean the load balancer is listening on port 80, and it is forwarding the request to your web server target, right? If you open this, the target group, web server TG. Now, let me just refresh. It should show as load balancer associated. Let me, or yeah, the load balancer is now showing web server LB. This two servers which are registered within this target groups are now doing their health check. It is an initial status now. So once the health status is passed, it should show up in the healthy status with two instances, with number two, right? And if for some reason if it fails, it will show you in unhealthy column. So let's just wait for the load balancer to become available. Still provisioning. So just give it a moment. Let's just check back in a minute. All right. All right. Our load balancer is now active. And let's just check the target machines and the target groups if it is showing in healthy or in unhealthy status. Let me refresh this page. All right. So we have two healthy target machines. Those are our web server 1 and web server 2. So now let me go to the web load balancer. And if I copy this DNS and go to the browser and paste it here, hit enter key. I should see the requests are being served from the web server machine. So currently it is showing 172.31.15.24, which is the IP address of our uh, first machine. Okay, and the IP address for the second machine ending with 10. So I should be seeing the request, the next request coming from the serving from the web server 2 machine. So let's just do the request is sending, and this has been responded from the other server, which is web server 2. So every time you hit this uh, DNS, it will fulfill the request from the web server, which is behind the load balancer. And most importantly, it is equally distributing the requests between two servers. In a sense, every request are being evenly distributed to the available servers behind the load balancer, which makes the web server, uh, in our case, it's a redundant web server, we can say. I mean, for an example, if I go to the EC2 instance and if I just uh, stop this EC2 instance, number one, which is the IP24. So this server, for some reason, has some issue, and this server is not functional. As a user, you would not know where this server are and how our requests are being uh, responded. All they were care about the request that they are sending needs to be fulfilled, right, as an user. And copy this one. There it is. So we have the request being answered from IP address 110 ending with. Let me just check. It should be the IP address of your server 2 machine 110. So now every time you hit this URL, the request will be served from the same machine because the other machine is completely down. So this is what it makes a redundant. If something goes wrong with any of the server behind the load balancer, you still have the other available server to fulfill your request. So that's pretty much about this video. I hope you like this video and you find this video as informative for your learning. And thank you for watching this video till the end. Stay tuned for more videos like this. Thank you again. Until then, bye-bye.